quite a few of these done, so we don't have too much. Let me start. So this one, what can I replace x with to make that inequality true? Well, you think about it. If I plug in 2, it works, right? If I plug in 2 over here, it works because the absolute value of 2 is 2, and that's less or equal to 2, yes. If I plug in 3, will it work? No. If I plug in 4 or 2.1, 2.2, so values that are to the right of 2 does not work. So I'm not going to aim my arrow that way, but I'm going to aim my arrow this way. But can I just aim it this way and say, hey, every value that is less than 2 will work here? Well, let's see if that's true. Well, 1 works, 0 works, right? 1 works, 0 works, -1 works, -2. So if you plug in -2 over here, the absolute value of -2 is 2. Is that less or equal to 2? Yes. But what if I plug in -2.5, which is right here? If I plug in -2.5, the absolute value of -2.5 is 2.5. And then is that less or equal to 2? No. So this arrow here can't go to the left forever and ever. It has to stop here. So the condition says that x can be any number that is from -2 to 2, and it will work. So another way of writing this is using brackets. That means inclusive, right? So -2, including -2, all the way to 2, including 2, can be the values for x. Now, if you look at the second problem says, what can x be? So we're trying to find, we're trying to find values for x that I can add to 3 to be greater than 4. So x can be, let's see, x it can be 2. 2 plus 3 is 5, is greater than 4, so that works. Can x be 7? Yes. 7 plus 3 is 10, is that greater than 4? Yes. Can x be 0? If x is 0, 0 plus 3 is 3, is that greater than 4? No, so x cannot be 0, so that doesn't work. So there are obviously some values that don't work. So what I like you to do is I like you to just on the side, forget what's inside here. Just think about this. What does this number have to be in order to be greater than 4? You can take the absolute value off and take it and be greater than 4. So let's draw an absolute value, a number line. Well, we just said that 4 doesn't work, right? So if I put a 4, it doesn't work. So I'll put an X right next to it. So 4 doesn't work. I got to take that out. 5, does 5 work? Yeah. So we're talking about, again, we're not talking about this, right? So just forget that for a second. Think about this. So 4.1 works, 4.2, 3, 4.4, 5. Everything to the right of 4 will work. Well, 3 doesn't work. 2 doesn't work. 1 doesn't work. 0 doesn't work. -1 doesn't work. -2. -3 doesn't work. -4 doesn't work. But, hey, what about -4.1? If I put -4.1, will that make my inequality true? Well, the absolute value of -4.1 is 4.1. And is that greater than 4? Yes, it is. So, and what about -5, -6? So you'll notice that every value to the left of -4 also works. We talked about this in class, and this is eventually be called an OR problem. So, in order for, so what I want here, right, for this inequality to be true, I need to take the absolute value of a number, right, in order for it to be greater than 4. They have to be less than 4 or greater than 4. So now that we understand that, let's figure that out. So what do I add to 3 so I can take the absolute value and be greater than 4? So it's these values over here, this value, right? When you add these two terms, and when you add, they either have to be numbers greater than 4 or numbers less than 4. So we set up an inequality. First one says x plus 3. So x plus 3, this has to be less than -4, right? Or x plus 3 has to be greater than 4. So those are the two conditions. Well, we're going to solve it. Okay, -1, -1, and x is less than -5. Or -3, -3. X has to be greater than -1. So let's try that, right? So let me graph my solution on the other line. The solution represents all the possible values of x. So it's saying here that x has to be less than 5, not shaded, or greater than -1, not shaded. So let's pick a number that is greater than -1. I don't know. Let's pick 3. Let's plug it in here. 3 plus 3 is 6, right? The absolute value is 6. Absolute value of 6 is 6. And is that greater than 4? It works. So if I pick 4, 4 plus 3 is 7. Is that greater than 4? The absolute value of that, is that greater than 4? It works. So any number that you can replace x with that is greater than -1 works. So that side is checked. So let's look at the left side. Let's pick -6, -7, -8. I don't know. Let's pick -100. Let's see if that works. Well, if you pick x to be -100, -100 plus 3 is going to be -97, right? And then you're going to take the absolute value of that. The absolute value of -7 is 97. Is that greater than 4? Yeah. So the values of x that will make this inequality true, as long as x is a number less than -5 or greater than -1, this inequality will work. So our solution is x has to be less than -5 or x has to be greater than -5. Those are my two solutions. All right, and this was an OR problem. Let's do the next one. X plus 3 is less. So this one was a little tricky. Some of you asked me that question. Now, let's think about this, and let's empty out what's inside. Let's just look at this. Take the absolute value of something so that when you take the absolute value of it, it is less than -6. Can you think of a number? Well, let's see 5. Take the absolute value of 5, and let's see if that's less than -6. Well, absolute value of 5 is 5. Is that less than -6? No. Take the absolute value, I don't know, of -2. Let's see if that is less than -2. Absolute value of -2 is 2. And is 2 less than -6? No. What we end up finding out is that with the definition, right? The absolute value of anything will always be 0 or a positive number. So when you take the absolute value of a number, it's always going to be 0 or a positive number. Now, if it's 0, is 0 ever less than -6? No. And if it's a positive number, is a positive number ever less than -6? No. So for this particular one, there is no solution. There is nothing that you can take the absolute value of, and it will turn into a negative. Next one. So for 16, 17, 18, so notice that they have a little extra, right? So for example, besides the absolute value, they have this 3 over here. We can't do this distributive property. We have to take the absolute value of whatever this is going to be and then multiply by 3. Okay? So what we want to do is simplify that a little bit. The first thing I'm going to do is divide this guy by 3, the left side by 3, and I'm going to divide the right side by 3. Notice that I divided by a negative number there. So, sorry, positive, so I don't need to flip the sign. So this and this goes away. I'm left with absolute value of 2x minus 4 is greater or equal to -3. Now, this presents another weird situation. So before we even start solving, let's think about our possible solutions. When is the absolute value? Think of the number. Take the absolute value of something so that it's greater or equal to -3. Well, in this case, because going back to the other problem, right, the absolute value of something always 0 or a positive number. So no matter what you put in there, you're going to take the absolute value will always be 0 or positive. And is that ever going to be greater or equal to -3? It's always going to be greater or equal to -3. So the solution to this particular one, right, is all real numbers. X can be anything in this world and it will work. All right, so I can replace this x here with anything I want. Multiply by 2, subtract 4, and whatever that is, take the absolute value. And guess what? It will always be greater than -3 because the absolute value of anything that you ever take will always be 0 or positive, and that's always greater than -3. So for this particular one, contrary to the previous answer, it's all real numbers. 17. Again, we got to do some simplifying. So let's take that. First thing, treat this as if it was something like this. 2k plus 6 greater than 6. So that's what I want you to treat, like a two-step equation. So you're going to subtract 6 on both sides and then divide by 2. That's what we're doing. minus 6, minus 6. This is 0. These two go away, and we're left with 2. Absolute value of x minus 9, we're going to divide by 2, we're going to divide by 2. So we end up getting x minus 9 greater than 0. So now that we simplified, we got rid of the 2 and the 6, we're looking at just x, the absolute value of x minus 9 greater than 0. So let's take that to the side for a second. Right, so let me remove this. Let me push this guy up just a little bit. So let's think about this. Absolute value of something, so let's forget the x minus 9 and just focus on this. When is that greater than 0? Well, let's draw an line. So, will 0 work? If I put in 0, will 0 work? Is 0 greater than 0? No. What about 0.1? If I put 0.1 there, and I take the absolute value, would that be greater than 0? Yes. So 0 doesn't work, so I don't shade it, but we're going to go that way, right? So values that are greater than 0 will work, and values that are less than 0 will work. So now how does that help us set up the inequality? We're going to say that x minus 9, the absolute value of x minus 9, has to be greater than 0, or the absolute value of x minus 9 has to be less than 0. And that's going to help us find the values of x. So, sorry. I put the absolute value. So x minus 9 has to be less than 0, or x minus 9 has to be greater than 0. So let's start solving. Plus 9, 9's go away, and x is less than 9. Or plus 9, and in this case we have that x has to be greater than 9. So let's graph that. So it's saying, here's my 9. 9 does not, it's not included, so it's either going to be greater than 9 or less than 9. Well, we can always try. Let's give it a shot. Let's pick a value to the right of 9. Let's pick 10. If I put 10 over here, will it work? Well, 10 minus 9 is 1. Take the absolute value of 1. Is that greater than 0? Check. What about 9.1? Think about 9.1. If I put 9.1 for x, I get 9.1 minus 9. I'm going to be left with 0.1. Is 0.1 greater than 0? Yes. So numbers to the right of 9 seem to be working, right? And you can check a few more. Let's try numbers to the left of 9. Let's try 8.99. 8.99, which is the left of 9, minus 9. 8.99 minus 9, sorry, absolute value, right? It's going to give us 0.1, the absolute value of 0.1. Negative, by the way. And if we take the absolute value of that, we get 0.1. And is the absolute value of 0.1 0.1? Is 0.1 greater than 0? Yes. Let's try a whole number this time. Let's try 6, which is about here, right? Let's try 6. Well, if I plug in 6 over here, I get 6 minus 9. 6 minus 9 is negative 3. Take the absolute value of negative 3, we get 3. And is 3 greater than 0? It works. So as long as it is not 9, everything else works. So x has to be less than 9, or x has to be greater than 9. So when you looking for values of x that you can plug in here to make that inequality true, you have two conditions here. You have an or. So x is either less than 9 or x will be greater than 9. Okay. All right. So it's not as bad, right? I mean, I'm always afraid of this one because sometimes it confuses, but it's not as bad. Negative 4, absolute value of 3x minus 1. We have to simplify a little bit. So let's divide both sides by negative 4. If I divide both sides by negative 4 in an inequality, I have to switch the signs. So it's 3x minus 1 absolute value, and it's going to be less or equal to negative 2. Okay, so this, and then again, so our next step is to just empty that out right? Empty the contents inside out. Just let's try to understand what's happening here. Take the absolute value of something so that it will be less than -2. Going back to, I guess, 2-3 problems before, we know that the absolute value of anything that we ever take will always be, so the absolute value will always be 0 or a positive number, right? No matter what. So there is no solution here because there's nothing you can take the absolute value of so that it's going to be less than -2, because the absolute value of whatever is in here will always be 0 or a positive number, and in both cases they're always greater than -2, not less than. So for that particular problem, this is again a no solution problem. Okay. This particular problem is a little special. -5, 2x plus 2, minus 3 greater or equal to -3. So let's simplify that first. So we're going to do add 3 to the left side and add 3 to the right side. These are going to go away and we're left with 0 on the right side. And then we get -5 times the absolute value of 2x plus 2. How do I get rid of the -5? I divide it. Divided by -5, and then divide the other side by -5. Now notice we're dividing by a negative, so 2x plus 2 is what's going to be left over, right? Because this simplifies to 1, but we have to flip the sign. So this is what I'm going to be working with. Okay, so I'm going to erase this guy, because it's not, and I'm going to get this guy, push it up. So imagine that's what we started with, right? So after we simplify. So now I wanted us to think, right? So let's empty the contents inside. Let's just look at this for a second. What can I take the absolute value of and be equal to 0 or less than 0? Well, start with 0. If I take the absolute value of 0, right? Take the absolute value of 0. Will that make that inequality true? Yes. So 0 is part of my solution. What if I take the absolute value of 1? If I put a 1 here, the absolute value of 1 is 1. Is that less or equal to 0? No, it's not. So we know already that I can't aim this to the right because numbers to the right just don't make sense, right? So they're not going to work. What about numbers to the left? What if I put -1 over here? If I take the absolute value of -1, it's 1. And then is that less or equal to 0? No. So the only thing that makes this, and I'll highlight it, this, oops, that's not highlighted, this true, right here, right? Not the top one, just focus here. The only value that I can plug in here, right, in here, is 0. So when you look at now this inequality, and we start thinking, I need to multiply 2 by something, add it to 2, and I have to make that equal to 0 because that's the only value that makes the inequality true, right? So 2x plus 2, and this is a little bit different than what we did earlier, right? So this 2x plus 2 is not going to be less than a number, or it's not going to be an and problem or problem, but I need to figure out what can I replace x with so that expression equals to 0, because it's the only condition that works here, right? I need to make this expression here equal to 0, because any other thing, it's not going to work. So, and based on that, this is the, not inequality in this case, but this is the equation that I'm going to set up. So, -2 on the left, -2 on the right. These two cancel out. I'm left with 2x equals -2. Then I'm going to divide by 2 and divide by 2. So x equals -1. So this is saying that the only value in this planet that I can replace x with right here, multiply by 2 and then add 2 to be less or equal to 0 is when x equals -1. So let me draw a number line here. I'm going to put -1. shade -1 because -1 apparently is the solution, but nothing to the left of it, and nothing to the right of it will make it true. Well, let's play it out. So let's take that and then I'm going to do it over here. So let's take my inequality, 2x, 2x plus 2 less or equal to 0. I'm replacing the x with -1. So we're going to get 2 times -1. Then we're going to add 2. And then less or equal to 0. Well, 2 times -1 is -2. And then we're going to add 2. And -2 plus 2 is 0. And if you take the absolute value of 0, is it less or equal to 0? Yes, it is. It does work. So when I plug x with -1, it works. Well, is there any other solution? Well, I'm saying there isn't. That's what we found. So let's just try. We don't believe fully yet. So let's just try. Let me pick, instead of -1, let me pick an easy number. To the right of -1, 0. Well, I get 2 times 0 plus 2 less or equal to 0. Well, 2 times 0 is 0, and then plus 2 is just 2 less or equal to 0. And we can see that it's not going to work because the absolute value of 2 is 2, and is 2 less or equal to 0? No, so 0 doesn't work, right? And again, you can keep playing with numbers just to, take negative 0.99, take take 1, 2, 3, 4, 5, and then take numbers to the left. You'll see that they don't work. So in this particular problem, it's a pretty different problem, right? It's a very unique problem. The only value for x, the only value for x that I can multiply by 2, add 2, and make this inequality for inequality equals less or equal to 0 is when x equals -1. Okay, so it's a little different. Okay, I'm glad we did it. Where am I? 20? No, 10. 20. -10 plus a half x minus 4 greater or equal to -10. Okay, first things first. Let's add 10 to this side. Let's add 10 to this side. So if this goes away, we're left with half x minus 4, absolute value, greater than or equal to 0. We can multiply both sides by 2. Right? That gets rid of this. And we're finally left with x minus 4 greater or equal to 0. So when is the absolute value of something? So now we can start thinking about this. Greater or equal to 0. Well, let's draw a number line. When you draw a number line, let's put 0. Will 0 work? Well, yeah. Will 1 work? Will 2? Will 3? Will 4? Will 5? Will 6? So in this case, every number including 0, okay, you can take the absolute value of, and it will make this inequality true. And likewise, any number to the left of 0 will also make that inequality true. So in this case, right, because we know by definition the absolute value of anything is 0 or a positive number, right? So it doesn't matter what I pick for x. I don't even have to solve for x here, right? Set up inequality to solve for values for x. This is all real numbers because it doesn't matter what I put in for x, subtract 4, it will give me the absolute value of something, and that something will always either be 0 or a positive number, and it will always make that inequality true. So the answer to that is all real numbers. So I guess you're looking at all these special cases in this one. Let's try the last one. 3, absolute value of a half, x plus 2 plus 6 less than 15. Where am I? So, step 1, minus 6 on both sides. We're left with 3, half of x plus 12 plus 2. All right, the 6's go away, less than 9. We're going to divide both sides by 3. And we're left with half of x plus 2 has to be less than 3. So, some number multiplied by half, added to, right? Take the absolute value of that, has to be less than 3. And we're looking for all the possible values of x that we can find. But before we do that, let's try to understand it. So, we're looking at something like this. Take the absolute value of something, and it's less than 3. What can those numbers be? Well, so it's 3. Will 3 work? No. Sorry, no. Will 4 work? No. Will 5 work? No. So numbers to the right of 3 doesn't work, but numbers to the left work. 3, 2, 1, 0, negative 1, negative 2, they all work. But when I get to negative 3, will negative 3 work? It won't. So I am limited to numbers between negative 3 and 3 in order to make this inequality true. So if I take any number from negative 3 to 3, plug it in here, take the absolute value, it's going to be less than 3. So now the problem though is, what can I replace x with? Multiply by half, add 2, so that it's going to equal to a number between negative 3 and 3. That's what I'm looking for, right? The values of x that will make that true. So this is an AND problem, right? So half of x plus 2, right, has to be between 3 and negative 3. I'm going to erase the top here, right, and I'm going to drag this guy, or these guys, to the top. I'm going to finish my inequality. So, we're going to, now it's a compound inequality, so if I subtract 2 here, I must subtract 2 here, and I must subtract 2 there. Here I get negative 5, less than half of x, less than positive 1. How do I get rid of the half? We're going to multiply that by 2, right? So if I multiply that by 2, the 2's cancel out to 1, and so I'll multiply everybody else by 2. 2 times negative 5 is negative 10. The 2 times a half, so this is x, and then 2 times 1 is 2. So we found out that the solution, the values for x that will make this inequality true, is any x value that's between negative 10 and 2. So let's graph that. It's negative 10, not including negative 10, and 2, not including 2. So as long as x, right, you pick an x value that is between negative 10 and 2, it'll make that inequality true. So, and where is our inequality? Let's go back to our inequality. Let me erase this. The inequality was, negative half of x plus 2. Let me just get the inequality back. Sorry, guys. Negative half of x. So we had half of x plus 2, right? This was what we had before. So let's pick a number. Let's just try it out. Let's pick a number that's easily divided by 2. Let's pick 8, negative 8. So let's plug in negative 8. Let's just test it out. If I take that, replace x with negative 8, multiply it by half, I get negative 4. Negative 4 plus 2 is 2, negative 2, and absolute value of negative 2 is less than 3. Yes. So let's pick another value here. Let's pick, I don't know, negative 6. Half times negative 6 is going to give me negative 3. Negative 3 plus 2 is negative 1. Negative absolute value of negative 1 is 1, which is less than 3, so that works. Let me pick a number that's outside negative 10 to 2. Let me pick, I don't know, let me pick 4. Right here. Let me pick 4. Just to prove that it doesn't work. So let's pick 4. If I pick 4, right? If I pick 4 and plug it in here, I get half times 4, which is 2. And then 2 plus 2, right, I add and I get 4. And is the absolute value of 4 less than 3? No. So, I don't know, you can try 2.1, try 2.2, try 3. Right, let's try 3. Let's go back here and plug 3 for x. Well, if I plug in 3 here, half times 3 is 1.5. 1.5 plus 2 is 3.5. And if you take the absolute value of that, is that less than 3? Also a no. So all that doesn't seem to work. So the only x values that work are numbers from negative 10, not inclusive, all the way to 2, not inclusive. So our answer is this. And then again, if you wanted to use the set notation, we can write negative 10 like that. Okay. We'll do a few more, but this one was a special set of problems because they dealt with a lot of the ones that like no solution, all real numbers, or we had a special one where it had actually to be exactly one number, right? X equals something. So that was kind of weird, right? Yeah, but that's it.